Hello and welcome to 15.3 Day 3, Operations with Radicals. Today we're going to be rationalizing the denominator, but to do so, let's first talk about when you square or multiply binomials. Okay, so don't forget squaring things just means do that same thing twice. So it's going to be 3 root 2 minus 4 times 3 root 2 minus 4. And then we've done this before with just x's and things like that. You're going to multiply the first terms together. Don't forget when you're multiplying radicals that you do inside, inside, outside, outside. So I'm multiplying 3 root 2 and 3 root 2. So outside, outside is going to give me a 9. Inside, inside is going to give me a root 4, or you can jump straight to the fact that it's going to be a 2. And then I'm going to multiply the first term times the last term. So I'm multiplying 3 root 2 times negative 4. Negative 4 is an outside number, 3 is an outside number, so together those are negative 12. And then inside, there's nothing else to multiply with that root 2, so we still a root 2. Same thing here, negative 4 times 3 root 2 is going to be the exact same thing. Negative 4 times 3 is negative 12, and then root 2 has nobody else to multiply with. And then lastly, negative 4 times negative 4 is going to be a positive 16. Okay, then just go clean it up. I know that the square root of 4, you could have done root 2 times root 2 is just 2. If you have the same radical twice, then it just cancels out and becomes the inside number, but square root of 4 is just 2. Which is now an outside number, so 9 times 2 is 18. I'm going to go ahead and combine these like terms. If they're the exact same index and radicand, so root 2 and root 2, then you just combine the numbers on the outside. Negative 12 and negative 12 is a negative 24, root 2, and then plus 16. 16 and 18 are going to be a 34, so my final answer is 34 minus 24 root 2. And that's my final answer. All right, so next we're going to go ahead and simplify the radical expression by rationalizing the denominator. All right, so what that means is that I've done all the reducing I can, but I have some sort of radical in the bottom, and you can't have that. We've actually done this before, hopefully, so this part shouldn't be too tricky, but adding an x and then talking about these bottom ones will be different. Okay, so we do have that inside, inside, outside, outside rule. So you can reduce radicals that are on the inside together and then numbers on the outside. But I have an outside 5 and an inside 7, so I can't reduce anything here. The only issue with this radical problem is that I have a radical in the denominator. So I'm just going to multiply top and bottom by whatever is in that radical. So root 7, multiply top and bottom by root 7. And then you just multiply straight across top. 5 times root 7, well 5 is an outside number, root 7 is an inside number. They cannot relate, so they literally just get pushed together, so 5 root 7. And then root 7 and root 7, those are both inside numbers, so if you need to do 7 times 7 is 49, you can go there, but root 49, if you have the same radical twice, root 7 times root 7 or root 7 squared, it's just going to cancel out the radical and just be a 7. So square root of 49 is 7, meaning my final answer is 5 root 7 over 7. So you can skip straight from here to here and skip that step entirely, but obviously do it. It doesn't matter. It's all the same. Okay, next one. Again, I've got an x on the inside. I can't reduce 1/2 any further, so I'm sort of stuck. The only thing wrong with this problem is this root x. Well, I want to get rid of that root x, so I'm just going to multiply it by what's inside the radical. So multiply by root x on bottom and root x on top. I don't care about the 2. The 2 is fine. I could leave a 2 down there, but it's just that radical issue. All right, so again, multiply straight across top. 1 times root x is just 1 root x, and you don't need to write the 1. On the bottom, outside is 2. Inside, x times x is x squared. Again, you could skip this step if you wanted to. I'm just going to show it to you anyway. All right, but what is the square root of x squared? Remember, I'm looking for groups of size 2. This is technically the same thing as saying x times x. The square root of x squared is just x because root x times root x is just the inside number. It's just x, and you're done. So I'm going to go ahead and write it nicely. So the top is just root x because I can get rid of that 1. The bottom is a 2. The square root of x squared, I'm looking for groups of size 2, is just x. Again, you could have skipped this entire step here and gone straight down here. Root x times root x is just x, and then 2 times x is 2x. All right, moving on to number 4. Again, if you can reduce beforehand, I would definitely go ahead and try that. But 3 and 32 can't reduce any further, so I'm stuck there. There's two ways to do it. You could split them apart and actually reduce this radical. Again, you're allowed just to break them apart and deal with them separately. So if you want to reduce root 32 to be 4 root 2, you could. And how I got 4 root 2 is 32 is 2 times 16, and 16 is 4 times 4. Again, you need to stop when I'm looking for a size 2, so I've got a group of size 2 there. So I'll go ahead and just do that over here. So I have root 3 over, and I'm on the bottom, I'm taking out a 4, and on the inside I'm stuck with just that 2. So if you want to break it down, you can. I don't recommend that, but I'm just going to go ahead and show you this process, and then I'll show you the way that I would just do it. All right, so this is what I have. You could even have this problem starting out. It's just like the last one. The only thing wrong with this problem here is just root 2. So just multiply by root 2 and multiply by root 2. The top is root 3 and root 2, which is a root 6. The bottom is 4 times nothing, or 4 times 1. And then the inside is root 2 times root 2, which is root 4, which really is a 2. Again, multiplying that number that's the same thing twice, it just goes away, so just a 2. Okay, so this ends up being root 6 over 8. So that's that answer. If you want to, and I recommend just going from here. So I'm going to go ahead and solve it a separate way. So I'm going to have root 3 over root 32. Well, the issue here is that root 32. So just multiply by root 32. This does result in bigger numbers, obviously, and you have to reduce it at the end, but that's okay. That's fine. I mean, reducing it here, reducing here, it's all the same thing in the end. Doesn't matter. All right, so multiplying 3 times 32, you're going to get root 96 over root 32 times root 32 is just 32. All right, I've got to break down 96. So 96 is 2 and 48. 48 is 2 and 24. 24 is 2 and 12. 12 is 2 and 6. And then 6 is 2 and 3. I'll go ahead and break it down one step further. 2 and 3. Okay, so breaking that top part down, I have a pair of 2's and another pair of 2's. So on the top part, I'm able to bring out 2 times 2 is 4. I'm able to bring out a 4, leaving 2 and 3 don't have partners. So those go back inside, pushed together. So that's a 4 root 6 over 32. Okay, now on the outside, I do want to go ahead and reduce outside, outside, inside, inside. So 4 and 32, what goes into 4 and 32 evenly? Well, 4 goes into 4 one time and 4 goes into 32 8 times. So 4 goes in here one time, meaning I don't need to write it down, and 4 goes into 32 8 times. So in the end, I still have that root 6 over 8. Do whatever you want. I mean, it's your math problem. But the issue in both of these problems is always that need to rationalize, that radical on the bottom. So whatever radical is stuck in the bottom, just multiply. Whether it's a root 2 and you got a number hanging out, or it's the entire bottom, who cares? Just multiply by whatever is stuck there on that bottom. All right, so this brings us to our next set of problems. These are all different than above. These have something minus a radical or something plus a radical, or it could even be a radical first plus a number. It could be written in any order. So these are a little different. You cannot just multiply by root 5 because it's not going to cancel out that radical on the bottom. So what you're going to have to do is multiply by the conjugate. So the conjugate is something that is the exact same thing with a different sign. I'm going to show you why that works here in a second. So if you ever have, so previously we only had just a root 7, a root x, and a root 32. They were just regular radicals in the bottom, no plus or minus. So if you have that, then just straight up multiply. But if you have something adding or subtracting, you have to use the conjugate. So the conjugate is going to be the exact same thing with the opposite sign on the inside. So 2 plus root 5. What you do on bottom, you have to do on top. Same thing. Okay, so 2 plus root 5. All right, so multiplying the top, you're just going to multiply. 1 times 2 is 2. 1 times a positive root 5 is a positive root 5. You're just going to multiply either that constant or that radical straight through on top. On the bottom, you're going to have 4 terms when you multiply. And that comes from, like we did that very first problem. 2 times 2 is 4. 2 times positive root 5 is a positive 2 root 5, because outside and inside don't go together, you just push them. Okay, then a negative 5 times a 2 is a negative 2 root 5. And then a negative root 5 times a positive root 5 is a negative root 25. Okay, and again, we're going to take shortcuts after this first one, but I'm just showing you how the math works out. So the top is still 2 plus root 5. Nothing changes up there. And usually nothing will change up there, otherwise it could have been reduced more. All right, on the bottom, we have a 4, and this will always be the case. You will always have a positive and a negative of the exact same thing. And this comes from the fact that I had the same things multiplying with the plus and with the minus. So your conjugate has to have a different sign so I can force this positive and negative thing, which will always cancel every single time. Also, another fun fact, this will always reduce. You're multiplying the same radical by itself. Root 5 times root 5 is technically just 5. I went ahead and showed it to you as root 25, but root 25 is 5. It will also always be a minus sign because a negative times a positive is always a negative. Okay, and then just go clean it up. So 2 plus root 5 is 4 minus 5 is a negative 1. Because it's a 1, I can go ahead and just clean it up by dividing, but normally it's going to be a number and you're just stuck. So I'm going to divide everything by negative 1, and I am done on this guy. Okay, so from now on we're going to do shortcuts. I'm not going to write this entire process out. I'm going to just do the first and the last. And if you need to write it out, you can, but you shouldn't need to. All right, here, exact same thing, but just change the sign in the middle. Okay, the top, 2, and again, this is parentheses. 2 times 5 is 10. 2 times negative root 2 is negative 2 root 2. Over. I guess I'll go ahead and do it one more time. 5 times 5 is 25, and then the last one we'll shortcut it. 5 times negative root 2 is negative 5 root 2. Root 2 times 5 is a positive 5 root 2. And then positive root 2 and negative root 2 is going to be a minus root 4, which again, last time doing it the long way, because there are shorter methods. Okay, 25 stays. A positive and negative will always cancel. And then this negative root 4 is just going to be a minus 2, because it's always going to be whatever's inside that radical. You can just save time. Okay, which is going to give me 10 minus 2 root 2 over 25 minus 2 is 23. And you are done. If this guy, if that was a 24, they would have all been even on the outside. I could have divided by 2 and reduced a little bit. All right, last one, I'm going to show you the shortcut. All right, conjugate is the exact same thing with a different sign. So 1 minus 3 root 2. Oops, root 2. Okay, on top, root 2 times 1 is root 2. Root 2 times negative 3 root 2, outside is a negative 3, inside is going to be a root 4, or you could have just written a 2 there. All right, on the bottom, 1 times 1 is 1. I am not going to multiply the inside and the outside. First, there's a lot of stuff there, save time. I'm just going to go multiply, because they're going to cancel. I'm just going to multiply the outsides, or the last terms. 3 times negative 3 is a negative 9. 2, root 2 times root 2 is root 4. I could just go ahead and put a 2 there, but I'll just go ahead and put root 4. Oops, whatever. There's parentheses, no big deal. Okay, let's clean it up a little bit. Again, all I did was get rid of that middle crossing out step by not multiplying the outer and inner terms. All right, on top, root 2 minus, well, root 4 is a 2, and then negative 3 times 2 is a 6. On the bottom, that becomes a 2. So then 9 times 2 is 18. 1 minus 18 is a negative 17. And again, we don't like to have negatives on the bottom, so I'm just going to divide everything by a negative. And also we like to have the number out front, but it doesn't really matter. But I am going to go ahead and divide and move it. So negative 6 divided by negative is positive. A positive root 2 divided by negative is a negative root 2. And then that 17 just becomes a 17. Again, if I had numbers on the outside that were all shared a common factor, I would divide, but this guy is done as is. So reminder, just The conjugate's the exact same thing, different sign. These middle terms will always cancel out, so you can save time by skipping that step. All right, see ya.